In this episode, an engineering project of epic proportions.
It's the weirdest sensation, it's really insane.
I think it's the greatest project I ever seen.
Harnessing energy on a record-breaking scale.
Just listen to that. That is the sound of huge quantities of water.
And the pioneering historic innovations.
Wow. It takes your breath away.
This is an amazing, but quite terrifying experience.
That made the impossible possible. China, the biggest manufacturer in the world, and soon expected to have the largest economy of any country on the planet. But all that success brings with it a major challenge. China is a country with an unquenchable thirst for energy. Something engineer and Shanghai resident Yangtze Akinola witnesses firsthand every day.
Living in downtown Shanghai, it's so easy to see how much energy is consumed on a daily basis. In this city alone, population has grown to 24 million people. That is why this country needs more energy.
China's traditional power stations burn as much coal as the rest of the world combined. But with fossil fuels a finite resource, China's engineers face a seemingly impossible problem. How to keep the lights on and China's dreams alive. Yangtze is on her way to see how the Chinese are looking to their landscape to provide the solution.
China has the greatest hydropower potential, more than any other country in the world. There are 23,000 rivers in China, and the Yangtze River is the mightiest of them.
With a population of around 1.4 billion and rising, if hydropower is to be the solution, China has to think big. The Three Gorges Dam on the Yangtze is an epic engineering project of a scale never witnessed on planet Earth before.
It is just incredible.
It's more than 2 kilometers long, holds back a reservoir of over 1,000 square kilometers, and is the largest producer of hydroelectric power in the world.
The area is prone to catastrophic floods. To lessen the possibility of flood damage and to create a source of clean power, engineers have dreamed of building a dam like this for the last 100 years.
Construction is now entering its final phase. For Deputy Director of Construction Technology, Mr. Qihua Ding, it's the challenge of a lifetime.
I've been working here for more than 30 years. I think it's the greatest project I've ever seen.
In order to create such a seemingly impossible structure and harness the power of one of the world's largest rivers, engineers need to draw upon centuries of innovation. Humans and the odd animal have been building small dams since the dawn of history. In the ancient Middle East, they realized that dams could protect from floods in wet weather and store water in dry seasons. But China's Three Gorges Dam will eclipse anything ever built before.
The Three Gorges Dam is the biggest dam in the world. It has a quantity of more than 2.8 million cubic meters of concrete.
With tens of millions of people living further along the Yangtze, getting the build right is literally a matter of life and death.
With millions of tons of water pushing against the wall, the residents downstream are really depending on this wall to stay up. Any imperfections and the consequences could be catastrophic.
Such a feat of concrete construction would be impossible without one of history's great innovators. In the early 20th century, the parched American Southwest was becoming desperate for both water and power. It was a problem that would require an epic engineering solution. And Professor of Civil Engineering Andrew Smith is heading for a bird's eye view of it.
Wow. This is the Hoover Dam. At the time of its construction, this was the world's largest concrete structure that had ever been built. Even today, roughly 80 years later, it takes your breath away.
The Hoover Dam was like nothing that had been built before.
Weighing in at 6.6 million tons of concrete, this was an unparalleled engineering marvel.
By attempting to tame the mighty Colorado River and harness the power locked within it, its engineers were setting themselves a seemingly impossible challenge.
The dam stands 700 feet tall and has a base thickness of 660 feet. The biggest problem and the biggest challenge was one of sheer scale.
The problem lies in the way that the chemical components of concrete react.
So what I have here is cement as well as water. And these are really the two main active ingredients in the curing process. Now, before it really starts to cure, let's quickly check the temperature. Before I dipped it into the concrete, the thermometer was already reading 44 degrees Celsius. Gives you an idea of how hot it is here.
It takes just half an hour for the temperature of the mix to reach its peak at 68 degrees Celsius.
So that's an increase from our original temperature of 24 degrees Celsius. And you could really, really feel the heat.
Engineers estimated that if they poured all the concrete in one go, it would take 125 years to cure and cool, meaning uneven setting and potentially catastrophic cracking. It was down to the project's general supervisor, Frank Crowe, to solve the conundrum. And what he came up with is still visible today in the old engineers' inspection tunnels, running deep within the dam.
So Frank Crowe, nicknamed here on the site Hurry Up Crowe, came up with an ingenious method for cooling the concrete to help it cure faster. The solution was to pass extremely cold water through 1-inch pipes. And the amazing thing is we can actually still see evidence of those pipes here.
In 1931, thousands of workers began constructing the dam out of a series of gigantic blocks. All the time cooling the concrete with ice-cold water, produced by a specially built refrigeration plant. And it worked perfectly. The whole job was completed in 1935, 2 years ahead of schedule. And the record-breaking dam even created a record-breaking body of water behind it.
This is Lake Mead. When the dam was erected, it became the world's largest man-made lake. At full capacity, they say, the volume of water could cover the state of Connecticut with 10 feet of water. As an engineer, this is an incredible sight to see.
Harnessing the power of the Colorado and the giant Lake Mead meant even now, over 80 years later, the Hoover Dam provides electricity to 3 states and brings light to some of the world's great metropolises. Impressive as the Hoover Dam is, the Three Gorges Dam is an incredible 5 times the size.
The height of the dam is 181 meters, and the total length of the dam is 2,309 meters.
The design requires almost 28 million cubic meters of concrete. In 1998, pouring begins. To accelerate the setting process and reduce risk of cracking, engineers take the techniques pioneered at the Hoover Dam to a whole new level. The ingredients are air-cooled even before they're mixed. High-speed conveyors take the concrete from mixing zone to site in just 15 minutes. And vast amounts of workers are used to pour an average of 20,000 cubic meters every single day.
In the peak period, more than 30,000 people took part in the construction.
Water cooling is supplemented with a mist sprayed over the working area to reduce the effects of the hot summer weather. The enormous concrete pour takes a total of 8 years.
In 2006, the whole dam was completed. It's the most important milestone of the project. Of course, I was very excited at that time.
But the engineers of the Three Gorges Dam project still have further challenges to face and will have to turn to the great innovators of the past.
It's a 3-story high marvel of Victorian engineering.
To produce more impossible engineering. At over 2 kilometers long, the Three Gorges Dam in China is one of the most ambitious engineering projects ever attempted. Built to tame the regular floods that hit the Yangtze River and harness the clean hydroelectricity potential of China's largest waterway. Engineer and Shanghai resident Yangtze Akinola has travelled to see firsthand how its creators are taking on this seemingly impossible challenge.
The Yangtze River is the 3rd largest and longest in the world, running at 6,400 kilometers. And the river is now the lifeblood for the thousands of people who live along it.
For Three Gorges engineer Qi Huading and his colleagues, completely blocking this busy and vital waterway is simply not an option.
The Yangtze River is the mother river of the Chinese people. It's the lifeblood of the people along this river. The cargoes passing through amounts 100 million tons per year.
To deal with the cargo ships, the Three Gorges team have employed a technique dating back to medieval times.
Here is the Three Gorges ship lock. It's the largest ship lock of this kind in the world.
The lock is more than 1.5 kilometers long and raises and lowers the river traffic 113 meters through 5 giant steps.
The ship lock is very busy. It works nearly 24 hours a day. And we take a very small time to maintenance.
But there's one element of this incredible engineering feat that doesn't suit all the vessels on the Yangtze.
It takes about 3 hours and 40 minutes or even 4 hours to pass through the ship lock.
Taking up to 4 hours to pass through the locks is simply too slow for the river's many passenger ships. So Mr. Ding and his fellow engineers face another gigantic conundrum. How can they get ships up and over the dam 8 times more quickly? Anderton, in the north of England. In 1870, designer Edwin Clark was employed to solve a particularly tricky problem. One that would be familiar to the engineers of the Three Gorges. He was asked to find a way to link the busy Trent and Mersey Canal with the adjacent River Weaver. A job desperately needed to speed up the journey times for barges carrying valuable commercial cargoes of salt.
This was a pretty stiff challenge for Clark in the late 1800s because the height between the canal and the river was about 50 feet. Transferring the salt from the canal to the river was time-consuming, laborious, and it was really slow. So Clark had to come up with an ingenious solution.
Almost a century and a half later, Dr. Rhys Morgan is still able to experience that solution himself.
Known as the Iron Spider, the Anderton is the oldest operating boat lift in the world. It's extraordinary. It's a 3-story high marvel of Victorian engineering. It's just fabulous.
Clark's mighty construction scooped up the barges and the water they were floating in and transferred them in one smooth action, 15 meters between the two levels. To do it, he used what was at the time a cutting-edge technology: hydraulics.
The basic principles of all hydraulic systems are defined by a law which was created by a French mathematician called Blaise Pascal. And it goes something like this. If you apply a pressure on a liquid in a closed system, then that pressure is distributed throughout the whole liquid in the system. And Edwin Clark used this to great effect with his boat lift at Anderton. He started off by making 2 watertight caissons. These are the tanks which held the boats and the water in which they floated. And he supported those caissons on top of 2 hydraulic rams. And there was a liquid in those rams and a pipe joining them both together. So as I exert some additional force to this hydraulic ram, I can start to see that the pressure is being pushed through the adjoining pipe and lifting up my other hydraulic ram. It's brilliant.
The design was genius in its simplicity. The 2 caissons were perfectly balanced, so all that was required to push the upper caisson down and so lift the lower caisson was an extra 5 centimeters of water. The result: an almost effortless rise and drop for up to 4 narrowboats simultaneously.
And most importantly, the journey time took less than half an hour, and that saved huge amounts of time and enabled the trade to be much quicker. It's just a fabulous piece of engineering. It's wonderful to be here.
Edwin Clark proved that moving boats between different water levels was no longer impossible. And his ingenuity inspired generations of engineers around the world. At the Three Gorges, in addition to the world record-breaking ship locks, its engineers are now in the process of creating a ship lift on an unparalleled scale. And Yangtze is getting a unique opportunity to ride on it whilst it's still under development.
It's the weirdest sensation, it's really insane. It feels like I'm in a big, massive swimming pool and being pulled up many, many meters up, or in a lift with a massive pool in it, being lifted up. It's an engineering feat, a beauty in so many ways, and super impressive.
Capable of carrying a 3,000-ton passenger liner, this vertical ship lift consists of reinforced concrete towers which support the huge steel pool. Instead of hydraulics, the lift will use massive counterweights and pulleys to lift the 132-metre-long pool and the vessel floating in it a vertical distance of 113 metres.
I think it's the best ship lift in the world. The counterweight of the ship lift weighs nearly 16,000 tons. I think it's a massive achievement for the Three Gorges Dam.
This world record-breaking lift will solve the seemingly impossible challenge of transporting passenger ships across the dam without frustrating delays.
For the ship to pass through the ship lock may take much more long time. So the ship lift is the fastest way for the boat to pass through the dam. The Three Gorges ship lift is the biggest in the world right now.
To keep passengers happy, when this is complete, it would take only 30 to 40 minutes of travel time from top to bottom. Now, this is a brilliant solution.
But the engineers of this mighty project have yet further challenges to face, and will again need to draw from history's great innovators.
This is an amazing, but quite terrifying experience.
To produce even more impossible engineering. The massive Three Gorges Dam in China. Stretching more than 2 kilometers across the Yangtze, it holds back a reservoir of over 1,000 square kilometers. One of its key functions is to reduce the risk of flooding in the region. Shanghai-based engineer Yangtze Ekinola has travelled to Hubei province to see how the dam's team are taking on this seemingly impossible engineering challenge.
Every 10 years or so, the Yangtze River floods quite seriously. In fact, over the last 200 years, there have been over 200 catastrophic floods, which unfortunately have caused over 300,000 people their lives.
Dams can help control the effects of excessive rainfall, but extreme floodwaters can also cause dams to collapse, with catastrophic consequences. One problem is called toe scour, when water spills over the top of the dam and wears the foundations away.
Now, if we imagine a flood situation where we have lots and lots and lots of water flowing over this dam, we've got all that water hitting the bottom of the dam. As we can see here, the integrity of the dam becomes very questionable and it starts to collapse. So there it goes.
The consequences of the giant Three Gorges Dam failing are almost unimaginable. So, to reduce this deadly risk, its designers need to look to one of history's great innovations. In the 1930s, construction began on the first large-scale dam on the French River Dordogne. Engineer André Coyne was given the job.
This is an amazing but quite terrifying experience.
Dr. Rhys Morgan is getting up close and personal with the mighty Three Dam.
I'm here with this huge dam behind me, and I'm stood next door to this overflow channel, and luckily for me today, the gates aren't open, because if the reservoir was too high, the water was overflowing, then the gates would be opened and some 700 cubic meters per second of water would be gushing out, flowing down this spillway, and I'd probably be blown away just by standing here.
The Three Dam is 90 meters high. The power of an overflow thundering to the toe of the dam has the potential to destroy the foundations. But Coyne had an answer, and the secret lies halfway down the gorge.
This is a ski jump spillway, so called because it has a lip at the bottom, just like a ski jump. And the ski jump prevents that water carrying all the way down to the base of the dam, where it can seriously erode the foundations. Instead of carrying on all the way to the base of the dam, it gets flicked into the air, and all that water turns into droplets as it's mixed with the air, and the energy is dissipated.
The Three Dam holds back 47 million meters cubed of water in the reservoir above, and its Director of Engineering Projects appreciates just how important Coyne's design is.
The ski jump spillway is necessary for the water to be transferred from upstream to downstream. Otherwise, the water would overtop and overflow the crest of the dam and then impact the toe of the dam, which would undermine the foundation and generate the total collapse of the dam.
Andre Coyne's innovation was a major milestone in dam engineering, and his ingenuity and foresight opened up a whole new world of possibility for dam engineers. Coyne changed the way dams were designed forever.
The colossal Three Gorges Dam uses a series of 46 ski jump spillways. When reservoir levels rise and water needs to be discharged, gates are opened, and the pressure shoots the water 100 meters from the vulnerable foundations of the dam, at the same time dispersing its kinetic energy. For Deputy Director of Construction Technology, Mr. Qihua Ding, the design is more than just practical.
The dam is a very beautiful structure, and the spillway looks like a piano.
When the spillways are in full flow, it's easy to see the potential energy locked within the Yangtze River. Chinese engineers want to capture it and turn it into electricity. But China is a country of around 10 million square kilometers, so the project needs to produce immense amounts of power.
I think the water power is very important to China because it's a very clean energy. The Yangtze River is a very big river, and we just get the disaster from this river. But now we can change the power energy into useful energy.
So how can engineers make the Three Gorges project the most productive hydroelectric power station on Earth? Man has always recognized the potential power of water for industry. Ancient miners built dams in order to collect water and then release a wave to scour the land. In the Middle Ages, Islamic engineer Al-Jazari designed dozens of ingenious water-powered devices, from irrigation systems to extraordinary clocks.
Have you got the time?
But it would be the Industrial Revolution that would take hydropower to another level. In 1834, British-born engineer James B. Francis arrived in the busy textile town of Lowell, Massachusetts.
At the time James Francis arrived here in Lowell, massive mills like this one were sprouting up all along the vast canal system. The mill complex ultimately would produce up to 160 miles of cloth every day. But the power began to run out.
With the industry's thirst for energy, the water in the canals became increasingly precious. It fell to James Francis to find a way to squeeze as much power as possible out of each and every drop.
The problem was that the mills here in Lowell were being driven by simple water wheel systems. These are relatively inefficient. They're driven by water falling into the buckets to make them turn, only using a portion of the energy available here in the canal system.
What Francis went on to design would change the world forever. And his original invention can still be found deep within the canal complex.
Wow. So this is it. This is the site of the very first James Francis turbine. The turbine is actually 5 meters below us. It's amazing to think that this turbine right here started the hydropower revolution.
James Francis took the idea of a water wheel and turned it on its side. He enclosed his turbine so water was in contact with the whole wheel constantly. And he added a series of vanes to direct the water at the optimum angle.
So here we have a deconstructed Francis turbine. This was actually one of the last turbines installed here at Lowell, and we can see how it works. So you can imagine the water would be guided in with directed vanes, then would hit these runner blades, and then if you watch here what happens, so as the water strikes the runner blades, it drops down and comes all the way out down below here. The sum total of all those enhancements led to nearly 90% efficiencies of the turbine.
It was so successful that even today, the Francis turbine is still the world's most used design.
Francis was a brilliant engineer who made a massive contribution to the Industrial Revolution.
The Three Gorges Dam is the biggest hydroelectric project of all time. So it's fitting that it should use the world's largest Francis turbines.
This is one of the 2 turbine buildings, and just listen to that. That is the sound of huge quantities of water traveling at up to 80 miles per hour, turning the 32 largest ever Francis turbines built.
Installing the giant turbines was an engineering feat in its own right. Each turbine weighs 450 tons, and the crane required to install them had to be factored into the design of the hall from the outset. And the UFO-like generators that convert the momentum of the turbines into electricity are some of the biggest of their kind.
These 450-ton turbines can generate the equivalent electricity of 25 million tons of crude oil, and wait for it, 50 million tons of coal.
The water enters through a series of huge inlets and falls 80 meters towards the Francis turbines, with a flow rate of up to 950 cubic meters per second. This torrent then rotates each turbine at 75 revolutions per minute, which in turn drives the generator above.
And each one of these turbines can, in a day, produce enough power to power over 16,000 TV sets. I think that is just amazing, really cool.
But generating the electricity is only one part of the challenge. The Three Gorges designers will still need to draw inspiration from history's greatest innovators.
Wow, this is truly awesome. We can see the nearly 170-foot drop.
In their quest to create their own modern marvel of impossible engineering. In 1994, work began on one of the most ambitious engineering projects of all time. China's colossal Three Gorges Dam is designed to combat catastrophic floods and produce vast amounts of hydroelectricity. But whilst its potential to produce energy is huge, the dam's location presents another seemingly impossible problem.
The dam is 1,000 kilometers away from Shanghai and other key industries lying in the east. Engineers needed a system that would deliver that energy huge distances with minimum losses.
And they wouldn't be able to do it without one of history's most extraordinary engineering dreamers. In the 19th century, distributing electricity was a big problem. But that would change when engineers decided to tap into one of the world's most awe-inspiring natural phenomena.
Here at Niagara Falls, 150,000 gallons per second pours over the top. 4 of the 5 Great Lakes of North America empty into the Niagara River and pour over the top of these falls into Lake Ontario to the north. As the water crashes over the top, all of the potential energy is converted into kinetic energy and comes down with tremendous force. Engineers knew that they could create a lot of electrical power with this. But the key challenge was not in creating the power, but in distributing it.
And if you know where to look, clues to how the challenge was overcome can still be seen more than a century later.
Wow, this is truly awesome. We can see the nearly 170-foot drop. That's the same drop as the Niagara Falls themselves, but we're over a mile away from the falls. And the water flowing through here right now is awesome.
Engineer Andrew Smith has tracked down the site of the Adams power plant, where tunnels redirected water from the Niagara River down this huge drop, driving electricity-generating turbines. Now, only one building is left standing on the site.
Wow. It may look like an old warehouse, but actually it's a really, really special place. This is the Adams Power Plant Transformer House.
In this building, history was made. And the man behind it was engineering genius Nikola Tesla. Once regarded as the archetypal mad scientist, the Austrian-born Tesla was an innovator and inventor who patented literally hundreds of groundbreaking ideas. And here, in 1895, one of his designs would be at the heart of the first large-scale generating plant in the world, a new super-efficient form of transformer.
Here you would have seen 2 rows of massive AC transformers. These stepped up the voltage from the adjacent power plant and distributed it directly from this building 25 miles down the road to Buffalo.
Tesla's transformers were the magic that made this groundbreaking power plant possible.
To demonstrate what a transformer does, we have the simple racetrack setup here. And I'm going to start by supplying the same amount of voltage to each track, just over 6.8 volts. Okay, so let's give it a try with both tracks at the same voltage. That's exactly what we expected. The dead heat. Now let's do the same experiment again, but step up 1 track's voltage with a transformer. So now, let's race. Sure enough, the stepped up voltage produced a faster car.
A step-up transformer works by sending power into a primary coil, which will create an alternating magnetic field. When a secondary coil that has more windings on it is placed beside it, that alternating field is transferred and, thanks to those extra windings, creates an output with a higher voltage.
And sure enough, that's reading almost 2 times what we had originally. Purple car should win. Perfect.
Instead of shooting cars down a track, Tesla's transformers enabled the power company to shoot electricity great distances across the country. A massive engineering breakthrough pioneered in this historic building, now considered to be the birthplace of the modern hydroelectric power plant.
The Niagara Falls power plant is now one of the world's largest sources of electrical power, providing up to 2.5 million kilowatts of electricity. Thanks to Tesla, the impossible was made possible.
At the Three Gorges power station, they're taking Nikola Tesla's innovative ideas and supersizing them.
This is the main transformer of the Three Gorges power plant. This is to change the voltage into a high voltage. For example, the voltage from the generator is 20 kilovolt, and this is to change the voltage into 500 kilovolt. The reason we step the power is we need a long-distance transmission. For example, we need to transmission the electricity to Shanghai. It's about 1,000 kilometers.
The Three Gorges power plant now generates almost 100 terawatt hours, supplying 9 provinces and 2 cities, including futuristic Shanghai, producing more hydroelectricity than any other facility anywhere.
Three Gorges power plant is the largest hydropower plant in the world.
When the giant shiplift becomes fully operational in 2016, it will signify the completion of one of the most remarkable engineering schemes in world history.
The Three Gorges Dam has been one of the most ambitious projects ever, taking tens of thousands of workers, 17 years to build, and costing billions of dollars. But in the end, it is truly an engineering marvel.
By learning from the great pioneers of the past, adapting, upscaling, and making innovations of their own, its workers have created a dam and hydroelectric power plant unrivaled on planet Earth. For engineer Qihua Ding, it represents the culmination of a lifetime's dedication.
It's my whole life work, and I feel very proud of this. I think the dam is amazing.